Assalamu alaikum warahmatullahi wabarakatuh. My name is Mahmoud Abdullahi Awad. I'm a Martin Rebellis B190015. Tonight I would like here to present part of group assignment group 7 subject power electronic. Title of group assignment DC motor speed controller using PID controller. Prepared Mahmoud Abdullahi Awad and Norman bin Zeno. Introduction DC motor speed controller using PID controller. Power electronic is considered with a wide range of converters that operate the power level rather than the signal level. One or more power electronic converter will make up a power electronic system. A power electronic converter is a composed of a number of power semiconductor devices that are controlled by an integrated circuit. Problem statement. The purpose of the project was to design a circuit for DC motor speed control using PID controller. However, the input voltage of DC motor speed control was from a DC generator that produced 12 volt output voltage. The output voltage of the DC motor was 24 volt since the input and output of the circuit were DC voltage. The usage of DC to DC post converter was implemented on the project as a voltage set up to achieve the desired voltage output. The PID controller in the circuit is an instrument that acted in the ministerial control application to regulate the output speed of the DC motor. Objective of the project. The objective of the project were to design circuit and calculate the parameters for post converter. Second, to simulate the design circuit using MATLAB.
Assalamualaikum warahmatullahi wabarakatuh. My name is Norman Besenu, DE100173, and today I will show the simulation for our project, which is DC to DC boost converter for DC motor using PID controller. Now, this is the circuit that we have designed for this project. On the top side of the circuit, it is the boost converter, while the bottom part is the PID controller. Before I continue with our simulation, I will brief a little bit about a boost converter and the PID controller that we choose for this project. So, our input is 12 volt from a DC generator, but we want to operate a DC motor which is 18 volt. So, we choose boost converter because boost converter is a step-up converter that will increase the input voltage to a higher output voltage. So, we have several elements in this boost converter, which is inductor, MOSFET transistor, we have diode, capacitor, and resistor load. So, I believe that Muhammad Abdullahi Awad have discussed about the value for all of these parameters. So, I will continue with the parameters for our PID controller. Alright, so this is the PID controller for our system. But before I continue with the PID controller, actually a boost converter is an open loop system. But we can trigger, but we have insert the PID controller, which it will become a closed loop system because PID controller will get a feedback from the output and it will calculate it until our desired output is same as the actual input. So it will calculate it until the output is same as the output that we wanted. Okay, so if we don't use the PID controller in this project, actually we can also use a pulse generator that we will connect it into this part of our MOSFET, which for this project we connected the G of the MOSFET with the relational operator. But if we don't use the PID controller, we can trigger the pulse by controlling the pulse percentage using the pulse generator. So, for example, if we set the pulse generator for 70%, so this output voltage will become 39 volt. So we must adjust the pulse percentage if we want to increase or decrease the value of the output voltage. But for our project, we use the PID controller to control the output voltage for this system. Now, I will continue with the PID controller for this boost converter design. As you can see here, this is 18 constant, which is 18 volt that we wanted for our project. Now the gain is 1 over 20. And for the PID controller, we have set the parameters into discrete time. And we only use P and I for this simulation. And after several tries and error, we get the actual value for P is 0.7 and the value of integral I, which is 100. Now we have done with the PID controller. We move to the repeating sequence. Alright, from here we can get the value of time values since our switching frequency is 20 kilohertz. So how we can get the value for this 0.0005? It is actually from 1 over 20 kilohertz. So we will get 0.0005 for this time value 0 and 00005. And our output volt values is 0 and 1. So relational operator here, it will show the difference between the values. For an example, such as if you can see the value here is 0.29991, so it will show if it is true, so the pulse will go into here and it will trigger our MOSFET, so we can get the actual voltage that we want. So I will proceed with the simulation for this project. We have set the time to 0.5 only because if we want to see the waveform really clear, we need to see it at a very short time. So we can see here that our input voltage is 12 volt and our output voltage, which is 18 volt, and from here we can see that our project is working, but we need to see from the scope to make sure that it is really working. So here, now I will explain our graph one by one. Since we use the PID controller for the system, we can see here that it have a very stable waveform and it have a not so high spike. So generally, if we start our system, and we must prevent it from having a very high spike because it can damage our system. So by using the PID controller, it's helped to cut any excessive spike here, so we can get a more secure and safe system. After that, it will become very stable at a very short of time. From here, it doesn't achieve 1 second, but it have already stable. So we want to see the voltage for the voltage waveform. So we can see here, this is the voltage waveform, and since our ripple is 2%, so the ripple or our waveform will not exceeding the plus minus 2% from the 18 volt. So what I can conclude for our project is, when we use a PID controller, we can get a very stable system waveform, and we can prevent our system from damage. And also, if we have a very low voltage supply, we can use a boost converter to increase our supply with correct parameters. And that's all from me. Thank you.
In conclusion, the project that has been discussed and recorded during the course is to build continuous mode boost converter when compared to the existing boost converter with a PID controller. The suggested boost converter with PID control profile improve voltage management, use overshoot, and improve converter performance. Boost converter in the traditional sense, this study succeed profiling away from achieving DC to DC and converting the goal of the lower side. Then instead output for turn. Verbose circuit is basic, straightforward, and adaptable. It was implemented without the use of any additional component, allowing it to maintain its effectiveness. Thank you.